This is going to sound a little bit kind of like a broken record because a lot of the points that I'm about to talk about have already been hit with a few variations. So what I want to talk to you guys about today is a case study on a project that I'm working on right now called Extreme Weather. This film is directed by Sean Casey, produced by Jen Casey. Sean Casey, perhaps you guys maybe know, he was the tornado hunter, with the TIV, the crazy machine that kind of embeds itself and then the tornado comes and then that thing is impenetrable. This is their next project that they're working on, which is basically showing about climate change and how we're destroying the world pretty much. Shot on a number of different cameras. We chose to use an ACES workflow for two main reasons. One, they have not agreed to do an HDR version, but this is necessary for this show with a bunch of glaciers and crazy highlights. I know that it's going to come downstream, so it's just very important to kind of maintain that the whole way through. Even though the money's not there now, I know it will be, so let's protect ourselves. We also decided to grade in Resolve. So the first thing that we did was take all of the existing cameras that were used on the show. Canon time-lapse, you had Red, Epic, a few Red Dragon shots, GoPro, and Panasonic GH4 on a drone. That all came into Resolve using just the built-in Resolve IDTs for the various cameras. The GoPro was a 709 actually, just a 709 IDT. And I guess, according to Robert, we're supposed to be saying IT, but that's kind of confusing with the guys that run the network cables, so I'm just going to stick to IDT as well.
I'm still calling it that.
Yeah. So essentially, once we got it all into Resolve, when you put it down on the timeline, it automatically converts that to ACEScc, not CG. CC is what we use at FotoKem, working through our DI workflows. So essentially, once it was in Resolve, we converted to ACEScc, did all of our color grading, all of our choices there. I'm totally open to receiving CDLs, so that's not a problem for me if there's any VFX houses that we're going to be working with in the future. The ACES color source then got exported to the SAN. Now this is each individual clip. I do most of my finishing on a Mystica for a lot of the reasons that we've pointed out today. Mystica works completely in floating point. You have paint tools that work in floating point. You have, instead of using LUTs, we have GLSL scripts. So we're using functional math to go in and out of color spaces. It avoids a lot of the problems that were brought up today. So that said, that's why we wanted to push it to the Mystica and do all the finishing on there. So we just pushed an AAF, rebuilt the project, and then in Mystica, it does not automatically convert to ACEScc. That has to be an implicit conversion that you go ahead and put into your stack. Why do we work in ACEScc? What are the advantages, right? And for me, it's three big ones. Filter freedom. I know that Kevin briefly touched on the ringing that you can get, the artifacts that you guys get with when you do applying filters in scene linear. The other advantage of ACEScc is that it works with legacy applications. So, it's essentially a log encoding. Photoshop will work with it. I have a lot of plugins that I use that expect, sRGB type values to come in. Familiar log grading feel, right? You talk to any colorist, and coloring in straight linear is a little difficult. So that familiar log feel is just what we're used to. It's muscle memory. It just feels comfortable. So I'm not going to spend too much time on this. I can skip over it pretty quickly because Kevin did a good job of explaining this. Essentially, I work in resolutions 8K, 6K, you name it, whatever the new K of the flavor of the month is. When we start to scale down, right, I usually like to use sync filters. If you have those negative values that we've talked about a lot today, you can get big problems on your filtering side. So you can see this is the original, and then this was actually scaled in ACEScc. This over here was just scaled in normal linear ACES. And you can see that you start to get a lot of artifacts, and not just the traditional ringing that we're all used to as sharpening, but actually the color can change. You can get fringes. That is definitely not good when you're in the DI bay. And this is caused, again, by what we were talking about earlier. This is 0 right here. A Lanxos filter has that little dip down here that goes below 0. So you're having overshoot and undershoot. On the sync side, you have that overshoot that goes above 1. So that's just something to be aware of when you're working in linear color space. But when you go ahead and convert that to ACEScc, all of those filters that we've grown to love become available to you again, and you can scale and interpolate freely. Now, just touching on some of the legacy applications, I have this really awesome $300 plugin that I love called Flicker Free, made by Digital Anarchy. On the time-lapse stuff, I run almost every time-lapse that comes through me through that plugin. That exists in After Effects. So by going an ACES export out to the SAN, going into After Effects, an ACEScc conversion, and then putting that through that plugin allows me to still use that plugin. That is, the algorithm that's built into it is expecting not a linear source. So that way I can still have the ACEScc files processed through that plugin and then get them back into the Mystica. Additionally, in Autodesk we do a lot of paint work and any kind of graphics or things like that. For them, working in a log format is just a little bit better as far as the paint goes. Again, Autodesk floating point. The other thing is that what happens when we send effects outside? So we work with a lot of third-party vendors. We use global data at FotoKem. It's a FotoKem technology that zips files very fast. And so we took the ACES standard linear files out, and we're sending them to Prime Focus and a place called South Bay to do a 3D conversion on that externally, and then we're going to be receiving those back in a week or two. Okay, so as far as the color grading, right? This is what I received back from the Resolve. You can notice that there's a big piece of black up here. We'll talk about that in a second. We do deliverable formats for a lot of different formats. That includes standard 1.8.5 theatrical, D-Cinema. In addition, we also do dome presentations. Those dome theaters require a 4:3 image, and typically there are some digital domes, but most of it is still film-driven. So the first thing that we do is we get the file in and convert it to ACEScc. Looks very similar to any other log file. The thing to notice is that all of that initial data that was there has been retained. We've just scaled that to 0 to 1 now. Everything is in a nice container that we can start grading with. I just decided to pick BT1886 to go out because, assuming this projector was somewhat of a 709 variation, this is what the general grade would look like. The next thing that we do is I use a linear bicubic mesh warper to kind of warp the top. And what I'm doing is I'm maximizing my X resolution and making a 4:3 frame that actually has more resolution than a straight crop out of the center. I could not do that unless I used ACEScc because, again, I'm using bicubic interpolation on top of that. You could get all kinds of crazy artifacts. The next thing that we do is we go ahead and put a Grad on the top because in a dome theater you have a lot of cross reflection. I've heard that you're starting to get that a little bit with the Barco, that escape format where you have the 3 projectors on either side. So this is just something to kind of help mitigate that. And then finally, we go back out. And so because we're using functional math, no pixels were harmed in the making of this film. Everything goes straight through. So 3D conversion, like I was touching on a little bit previously. So we've sent out a lot to be converted, but clients with ever-increasing budgetary pressure want to do more and more in the DI bay. And the Mystica has all the tools to do that. So we do a little bit of that in-house as well. I tend to pick my shots carefully and just get the easy ones, send the hard ones out. So this is just a quick example of what we kind of do. This is final grade. We pull keys, rotos, whatever we need to do to get a nice little depth map, and then ultimately put that all into package, all working in ACEScc. And then finally, there we go, we map it onto the cards, shoot it with 2 cameras, and you get your parallax. Get a little bit of 3D going. That takes us to deliverables. So once all of the work's done, all the creative choices are made, the story has been promoted through color, and we're ready to actually start to ship out to the theaters, the first thing that we got to do is make the 2 masters. Now the 2 master versions are dictated upon the aspect ratios. We make one that's a 1.8.5, and the other one that was the 4:3 that I just walked you through the creation of. From that, those 2 masters then go through our Nuke render farm and through the OCIO conversions. Using OpenColor, we can make 709 DPXs that are your HD source, your UHD source, anything for Vimeo, YouTube, whatever web. And from the 1.331, we generate log DPXs for film out, and then XYZ TIFFs for the IMAX laser. Essentially, the beauty here is that if I make a mistake, which happens very rarely, but when it happens, I only have to fix 2 files, and that's amazing. And the scripts make all the other deliverables.